take a look at how video creators can take advantage of the amazing performance available in RTX Studio laptops to tackle some of the toughest editing workflows. To start with, we're going to take a look at editing 8K red code RAW in DaVinci Resolve. So my project here consists of a number of 8K videos shot on a RED camera. Now, we're not only using 8K RED files, but we can also see here when I take a look at my project settings, we're also using an 8K timeline. Now, one of the interesting technical details about working with RAW files is that you're starting with raw sensor data, which are the actual readings of the light intensity values that strike the sensors, not the color values. Each frame has to be debared in real time, which means that for each pixel, we take the known single color value and then query the surrounding known color values of the other pixels to generate full color information for that individual pixels. That process must be repeated for every one of the over 33 million pixels in the 8K frame, and then repeated again for 24 or 30 frames every second of the video. Previously, users would need to use a dedicated PCIe card called a RED Rocket to perform this decode and debear. But through NVIDIA's work with RED, we can now perform both the decode and the debear on the GPU for real-time processing of red code RAW, eliminating the need for this expensive custom-built add-on card. Blackmagic Design has incorporated this functionality into Resolve 16, providing GPU decode and debear support for RED files, as well as GPU accelerated decode for their own Blackmagic RAW files. So with my RTX Studio laptop, I'm able to take advantage of the decode and debear features in Resolve to smoothly play back my video in real time. Editors are also able to smoothly scrub the timeline, finding exact positions within their video files, speeding up the editing process. Resolve 16 leverages the GPU to perform a wide variety of editing, as well as full color grading and video correction effects. Let's take a look at how we can utilize some of Resolve's features to fix some common issues in our video. Looking at our video here, we can see that we've got a bit of a problem. Our editor wants to use this particular shot, but our secondary cameraman is clearly visible in the shot, ruining the take. But is it really ruined? We could manually mask our cameraman from each frame, but let's see if we can use the built-in tools to give ourselves a head start on cleaning up this shot. Let's start by adding an outside editing node. Now with that node selected, we'll create a quick mask around our cameraman. Nothing fancy, we just want to isolate our cameraman from the rest of the shot. Okay, so let's go ahead and activate Resolve's built-in tracking tools. We'll turn on the interactive tracker and let the GPU accelerated tracking functions match our mask movements to the movements of our cameraman. This lets us make sure that the mask covers him throughout the entire shot. With that complete, we'll go ahead and turn off the tracker. Next, we find our object removal function. So this is the GPU accelerated object removal function inside of Resolve. Real quickly, we'll just turn on the mask so that we can see the mask selection is tracking our cameraman throughout the entire sequence. And now we'll just go ahead and apply our settings for the removal tool. Turn off our mask, build the clean plate, and boom, we instantly remove the cameraman from the background. We can see that as we track through the sequence, while the removal isn't perfectly clean, it's certainly given us a head start to saving this shot. When working on a video project, a common task is to slow down the action, giving viewers a chance to appreciate a particular action sequence. Resolve has introduced its neural engine, which utilizes GPU-accelerated AI-based neural networks to improve the results for things like slow motion effects. NVIDIA's RTX GPUs include integrated tensor cores designed to accelerate AI inferencing functions. Let's take a look at conventional methods for retiming video and compare them to AI-based retiming. We'll be retiming the first clip in our sequence to 50% of the original frame rate. With the default retiming method, frames are just repeated to match the new slower frame rate that we've applied. This makes our final output look jerky, which definitely isn't the finished look that we want. Next, we'll take a look at optical flow. Optical flow is a more advanced retiming method, which looks at the first frame and the next frame and uses that information to create new frames in between. Here we can see that the motion is smoother than the default retiming method, but optical flow has created motion artifacts while attempting to create new frames. We can see obvious warping and bending in the created frames, and the legs of our subjects look especially unnatural. Finally, we'll take a look at how speed warp improves optical flow. Speed warp utilizes the Resolve neural engine to apply a GPU-accelerated trained neural network that improves the accuracy and output of the frames that optical flow creates. When we take a look at the same areas where optical flow alone showed artifacting, we see that optical flow with speed warp now shows cleaner slow motion. Let's take a look at another AI tool in Resolve, face refinement, and show how we can use it to easily transform our subject without affecting the rest of the scene. First, we'll select one of our correction nodes and apply the GPU accelerated face refinement function. Once that's complete, we'll activate the Analyze feature within the tool. Analyze will track our subject's facial features across the entire clip, and once the Analyze process has tracked the facial features, we'll be able to make localized adjustments to modify specific facial areas. For our example here, we've decided that we want to make our subject the villain. We'd like to give him a much rougher, more harsh look that lends an air of menace, so we're going to use the face refinement features to achieve that. Next, I'm going to switch the operating mode of the tool to Beauty Advanced, and that's going to give me a little more detailed control over my adjustments. Normally, we would use beauty tools such as smoothing and lighting to reduce facial blemishes and create a softer result, enhancing our subject's natural good looks. However, the flexibility and performance of the tool means that it'll work perfectly for our needs. So instead of increasing the smoothing and softening the lighting, we're making our adjustments in the opposite direction, adding harsh lighting and increasing the facial contrast to create a rough-hewn look. I'm going to intentionally make my adjustments overly aggressive to start with, and we'll see why later on. Now, I can use the eye tools to affect just the eyes and bring back some of the details that's gotten lost in my overall facial adjustments. The eye bag removal tool allows me to bring more focus to my subject's eyes quickly and easily. Now, I mentioned earlier that I was being overly aggressive with my adjustments, and the reason for that is that I can now use the global blend tool to easily dial in just the right amount of adjustment I want for my final look. We can toggle the effect on and off to show how these adjustments have given my subject a dramatically different look and created that harsh, aggressive look that I wanted. So now I'm going to go ahead and scrub the scene, and we can see that the adjustments that I've made to the face track across the entire clip. Not only that, but if we look at the subject's clothes, we can also see that the adjustments are localized to just the face, and they haven't affected the rest of the scene. Face refinement, retiming, and object replacement are just three of many new AI capabilities enabled by RTX Studio laptops running DaVinci Resolve 16. Being able to do all of this, as well as being able to work natively with red raw 8K footage, all while working on a laptop, revolutionizes your editing workflow.